Hey, hello everyone. So what we have here is actually a passive infrared sensor or PIR sensor. So this PIR sensor, let's open it up here. As you can see, the sensor, based on this little transmitter RF circuit here, actually sends a signal out at 434 megahertz. Outside of that, it's got a dip switch which allows us to set the permutation. So the signal that's coming out of this transmitter is fairly unique. So if you've got multiple of these PIRs, it's still going to be a unique signature for each one. What I have here is actually a stripped down version of the same sensor. I pulled apart the circuit board. So what's of interest to us here is actually this chip, the P22262, which is the encoder chip that encodes the signal that's coming out of this PIR before it sends to the transmitter. So this is the one that takes the input from the dip switch and generates a unique pattern, which obviously, given the number of switches that you see here, six different switches, you could have a potential of 2 to the power of 6 different combinations. So the chances that it will interfere with another pattern is pretty slim, right? Okay, so our project is actually to be able to read the signal that's coming out of this PIR and hopefully make a microcontroller that can trigger a relay or an LED or something after it receives a valid signature. Right. So the first piece here is to actually hook up a sample circuit. What we have here is a 433 megahertz receiver. It's from Radiotronics and it's called the RCR 433RP. So I've got 2 probes which are connected to my oscilloscope here. So the oscilloscope you see here is a disco USB oscilloscope. It's actually pretty cool. It allows you to read the logic and display it on the computer. So let's do a quick test, right? So the first thing I'm going to do is on my computer. You see the screen here. So you see the screen here is actually the scope, the screen of the scope. We'll turn it to recorder mode and then make sure the probe 1 is on, right? And then send a test signal and see how it looks. Okay, see a little bit of jerk up. Let me try that again. Okay, there we go. That signal looks a lot better. So if we keep scrolling, let's see where the signal starts. Okay, this is all just a random noise that the receiver is picking up. And it looks like the signal is actually starting right about here. So you see the pattern. Let me zoom out a little bit so the pattern's a little obvious. But as you can see, the pattern here keeps repeating itself. It's got the same number of highs and lows, the same number of pulses in each pattern. It looks like the pattern is repeated, about 5-6 times or so. So this pattern is actually what is transmitted by the encoder chip that we looked at earlier. And if we zoom in here a little bit, based on the data sheet of the encoder, you can make out that a small pulse followed by a long pulse here is considered a floating bit. So a floating bit is when the microcontroller pin is not connected to either the positive or the negative of the power. And if you look at this signal here, 2 small pulses, that's considered a logical 0, and then these 2 large pulses is considered a logical 1, right? So based on this pattern, it's fairly easy for us to actually develop a microcontroller program which can read this data, interpret it, and interpret it for every specific dip switch setting or the pattern. Right? So let's fast forward a couple of weeks. And then what I have here is actually the final circuit. As you can see, my final circuit uses the same RCR433RP receiver. I'm using a PIC, although it's kind of difficult to see in the video here. I'm using a PIC 12F683. So it's one of the baseline. Oh, it's actually more of a mid-range PIC. It's an 8-bit PIC, and then it's got a bunch of different functionality, the full details of which you can get from the data sheet. Right. So what I'm going to do here is actually turn this circuit on so you can kind of see how this whole thing works. I've just got to plug the power supply back in. Okay. So this is a basic breadboard model. As you can see, in here you have the receiver. That's the PIC. This is a little relay that is triggered every time it receives a valid signal. A little push button I'll explain in a little second, and then you've got a standard 3mm LED. So the first thing is, if you notice, if I hold this push button down for about 5 seconds, the LED turns on. So this is essentially to set the circuit to learning mode. So I can, this allows you to actually set a new dip code out here. So as you can see, I can change this, although it's not real clear, but I can actually change the settings on the dip switch. So let's say we turn 1 on, 2 off, turn 3 on, and then 4 off. And then 5 is on, and then 6 is off. Right. So after you set the pattern, now the circuit is actually in learning mode, which is indicated by the LED glowing. Right. And if I transmit the signal, you can see now the LED actually received the RF signal, it decoded it, and it remembered what the signal that was sent from the RF receiver. So the next time it is triggered, which I can actually do by hitting this little tab switch, which sends a test signal, you can see the LED blinking, indicating that it has actually received a valid code, and in this case it will actually trigger the relay circuit for about 15 seconds. Right. So let's say now we change the code here just for a test, and then try to send a test signal. Obviously at this point, LED is not going to be activated because it's not programmed with the new code. So if I want to change the code, it's as simple as holding down the program button for 5 seconds, and then transmitting the new code, which it remembers, and then voila, there you go. The next time you actually send a signal, it's actually going to respond to that particular type of signal. Right. So the other cool part about the circuit is, even if you actually pull out the power supply, it's still going to remember the code that was programmed in, because the code is written into the EEPROM. So the next time it pulls up, it actually reads the EEPROM to see if a valid code is present, and if it's present, it activates. If there is no code present, it automatically goes into learn mode, which is indicated by the LED coming up solid. Right. So that's the basic of the circuit here. Hope that was useful. If you guys need more information, you can get the source code, a little more of the details from my blog, which is blog.mindfront.net. Otherwise, if you've got any comments, let me know. Thanks.